I'm the biggest monster that you've ever seen. My eyes are...
Hello! Continue on to section 2.7, absolute value and functions and graphs. We need to graph 4 times the absolute value of x minus 3 plus 1. We need to list the vertex and the x and y intercepts, if any. So in order to understand this problem, if we look at it, what is the problem asking you to determine? Well, it tells you. We need to find the vertex, so we need to know how to get the vertex. And we need to figure out, well, does it have any, or if it does, what are the x and y intercepts? Now, in order to get or graph this translation, okay, we need to know, well, what is the parent function? And if we know it's an absolute value, if we think back to just the last section, we know y equals the absolute value of x. If we need to, let me skip just down here to number 4. If we need to graph that parent function, remember, if you're not sure, we can always plug in values. Plug in 0, you get 0. Plug in -1, you get +1. Plug in +1, you get +1. Plug in -2, you get +2. And the graph goes up in this direction and also in this direction. So there's my parent function. So we need to figure out, well, how does this shift? In other words, what do we know about this function? On the outside of the absolute value, we have a +1. So we know that, remember, on the outside, if we add or subtract, it's a vertical shift. So we know it's a vertical shift of 1. On the inside, what makes that 0? X minus 3 equals 0, so therefore x equals 3. 3 is to the right. We can say that it looks like a V, not on the origin. Okay, so we know it's going to have 2 shifts, and then the 4 being multiplied tells you it is a stretch. Okay, so there are multiple transformations. 3. Okay, what transformations do we need to apply? Well, the ones that we just said. We need to go up 1. The vertex is going to travel up 1. It is going to go right 3, and it is going to be a stretch of 4. So horizontal right 3, vertical stretch by 4, and up 1. What is the vertex of that function? Well, let me rewrite it for you. If we had y equals 4 times x minus 3 absolute value, and then plus 1, okay? Remember, to find that vertex, we're going to start with the x. Start on the inside. What makes that 0? And if we say 3, so y equals 4, 3 minus 3 plus 1. You'll see that y equals 4 times the absolute value of 0 plus 1. Therefore, y equals 4 times 0 is 0, plus 1 is 1. So we know our vertex is, it starts at 0, 0 for the parent function. So vertex equals 3, 1. What are the x and y intercepts of the function? I accidentally did not erase that. So there are no x and y intercepts, or x-intercepts. How do we know that? Because of the 4 being positive, we know that our vertex is above the x-axis here. And because it's positive, our V shape is going to go up, so it never will cross the x-intercept. So if we graph this, let's plug in just a couple points. Notice, let's go 1 over from the vertex. So let's go to 2, and we can do 4. So if x equals 2, plug into our equation. 2 minus 3 is -1. Absolute value of -1 is 1. 1 times 4 is 4. 4 plus 1 is 5. So when x equals 2, y equals 5. And when x equals 4, you get 4 minus 3 is 1. 1 times 4 is 4. 4 plus 1 is 5. So those 2 points. Okay. If we needed to do one more, let's go to just 1. And then hopefully it's the same mirror image for 5. Okay. 5 minus 3 is 2. 2 times 4 is 8. 8 plus 1 is 9. So we would have to go all the way up to 9, which is the very top up here for both 1 and 5. If you notice, our V is a little bit stretched, a little bit more narrow, or narrower. Last part. Without graphing, we need to identify the vertex, axes of symmetry, and transformations from the parent function. Quick definition, if we don't remember axes of symmetry, it's that line, that vertical line that goes through our function and splits it into a mirror image. In this case, let me use the red pen, the red dotted line, this horizontal line right here that splits our V into both equal or symmetrical sides. That is the axis of symmetry, which is a vertical line. All vertical lines are x equals, and the x equals through that point is x equals 3. Okay. So if we look at y absolute value of x minus 4, we're going to identify the vertex. Vertex, remember, what makes this 0 is 4. Is there anything left? No. So our vertex is 4, 0. Our axis of symmetry goes through the vertex at that x coordinate. So we'll say x equals 4. And then, is there any transformation? Transformation is, all we know is that it's a shift right 4. Do the last 2 bullets. Notice I erased the third one down. So kind of skip that one. Do the last bullet and the second bullet. Welcome back. Vertex. Here, 0 goes in. -2 comes out, so 0, -2 is our vertex. Where does it go through for the axis of symmetry? It's whatever the x coordinate is, so x equals 0 is our axis of symmetry. What do we get for the shift? You should have gotten, if you notice, because of the negative, it is a reflection across the x-axis. It is the 3 tells us it is a vertical stretch by 3, and it also went down 2. Hopefully you moved the 5 over behind a little easier to understand. So this is just plus 5. So that gives us, you should have said a vertex of 1, 5. Axis of symmetry was x equals 1. And the transformations were, right, 1. It was a reflection across the x-axis. And our graph went up 5. Don't forget, do your best, forget the rest. Bye, 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 bye for now, you tough mutters.